Okay, I thought I'd take just a second to make a connection here in this last example that I did, showing that a function is not one-to-one. If we're going to show that a function is not one-to-one, I didn't really mention this in my last video. Formally, the way that we're going to understand how to do that is we're going to take the negation. We're going to take the negation of this definition up here. And remember that if we negate for all, we're going to end up with there exists. So that show that a function is not one-to-one. I took the negation for there exists A and there exists B. And then we would need the negation of this conditional statement in the definition. And back when we started talking about truth tables or logical equivalence, this may have been one of the equivalences we looked at. If not, this is real easy to verify using truth tables that the truth values are the same. If we negate the conditional proposition, that is logically equivalent to P and not Q. Right? So that's what I've done. I've taken this as P and this as Q, and in the negation we've got P and not Q. Right, so going back to the last example from the last video, we can see that this statement is really what we were using. F of A and F of B are the same, and at the same time we had that A was not equivalent to B. So you know, if you left off the last video and everything made perfect sense, and then I came in here and looked at this formal definition and that messed everything up, you could probably get by. If you didn't make perfect sense out of what I was saying with the formal definition, that's probably okay. But I thought it was worth mentioning to make the connection. I probably should have done that in the last video, but I was running short on time and I was trying to finish that example. So anyway, hopefully that helps to clear things up a little bit.